Hello guys. We're going to be working with the benchmark questions. So we're going to go over them. We're going to be taking one question at a time. You'll be able to select from a group of questions. You select whichever one you think you want to work with first, and then you can go ahead and continue until you finish the test. Whatever strategies I do, I need for you guys to complete them as well. I do want to see that on your test booklet. Remember, this is for a grade. This is going to benefit us because it'll help us for the remainder of the school year, for other questions, for other tests. So make sure that we follow along as I'm speaking. So do not mute me. Please do not do that. I have important information that I need to give you, as well as written information that I'm going to put here. So right now, let's go ahead and go to question number 6. Here's question number 6. It says the graph shows the distance of an object traveled in 11 seconds. Okay, so we're talking about distance, and this was traveled in 11 seconds. When we look at the graph itself, we see distance is going in meters, and as we look over here at the bottom, we're going time in seconds. If you remember when we talked about distance time graphs, we said that when we see the line that is going straight at an angle, we have constant speed. Okay, this is constant speed. When we're talking, and this is because we're talking about distance, this is referring to, or this line says, the object is moving away from home, away from home, away from home, or away from the starting point, away from the starting point. The object is moving, if you remember, at a constant speed. So I can already, as I'm going over my strategies right here, I'm going to put constant speed. And then as I get to the 10 meter, I see that the object got to 10 meter. Now, another from 6 to 7 seconds is still at 10 meters away from home. And then I go 7 to 8 seconds. I'm still at 10 meters away from home. So then right here, this is what I would call at rest. Now, this is a distance time graph. If this were a speed graph, then I would say the object is going at a speed of 1 meter per second, 2 meters per second, 3 meters per second. So then that is not the case. This is distance, okay? So if this would have been a speed graph, this would have been acceleration. But this is distance. So once again, this is constant. This is at rest. Now, if I wanted to know my speed, okay? If I wanted to know my speed, I would do distance over time. I would put the distance traveled from 0 to 10 meters. So it would be 10 meters. And in how long? I would say in 6 seconds. Okay, so, but that's for another one. I'm just saying what it could have been if this was speed. So now I'm going to look at my possible answers. I haven't even looked at them. Okay, so right now all I did is analyze the graph based on the information that we know. Once again, distance versus time means the object is moving away from home. Do not forget that we mentioned before that depending on the slant or the angle of the line, that's going to say, okay, I'm going a little fast. This one's going, I guess, a little bit fast, not very fast, because you could go faster. But if the line was slanted this way, then you would see from here to here, it took me a longer time to travel, less of a distance. That would be like it's 7 meters right here in a total of 10 seconds. Now, so this less of a slant, I'm going to be going slower. More of a slant, then that means I'm going faster. If I would have been right here, look at, in 4 seconds, I would actually make it all the way up to 11 meters away from home. But that's just, like I said, analyzing the graph. So then let's look at the possible answer, or the information that we need. Which answer choice best describes the movement of the object between the times of 0 to 6? And if we go back, this is 6 seconds. And this is 0 seconds. So then we need the motion from here to here, so we can say it was constant. So let's look at the possible responses. Moving at a constant speed. I'm going to put a question mark because we always go with the best possible answer. What if there's one that is asking going at a constant speed, and then they're asking for the speed? So then we would go here and do the calculation as to how fast the object was going. And once again, we would do that by using distance over time, because speed equals distance over time. Is it accelerating? Is it gaining speed? Is it going faster? Is it going slower? Is it slowing down? Is it speeding up? And we don't see that happening right here. We just see that it stopped. So if they were to ask information from here to here, we would say, you know what? It stopped. So from here to here, we could say that from, let's say 5 seconds all the way up until 7 seconds, it slowed down and then it was at rest. But no, there's no acceleration between these 2 points. So no. Is it moving toward the north? Distance graphs really don't give us direction that the object's moving. It's just saying the object's moving away from home, or if we had a line coming back, then we say it's going back home or back to the starting point. So no, that's not the case. Did it stop? Well, if they had told me what happened from 6 seconds all the way to 11 seconds, then I would have said it stopped. But in this case, we're looking at 0 seconds all the way up to 6 seconds. And here's my 6 seconds. So I'm measuring from here to here. So I'm going to this dot that I created over here. So the correct answer is letter A. So go and choose the next question that you think you want to work with first until you finish with all 38 questions. Thank you so much, guys. I'll be seeing you.